about fall protection for these applications. We're going to be going off of the EM 385 rules since we mostly do DoD work. And if you have any questions during the presentation, just let me know. Thanks.
Hey, Andrew, this is the new ones, the new EM 385?
Yeah.
Okay.
A lot of it is the same. I did update some of the references, but for the most part, it's pretty much the same stuff.
Okay, that's good. Good to hear.
Yeah, there's not a whole.
Yeah. Go ahead.
There's not a whole lot of changes other than they reorganized how they the hierarchy of like naming and stuff like that. So
Okay.
at least in this section 21, there wasn't a whole lot of substantive changes that I could see. But if you know something I don't, let me know, please.
No, I'm actually still working. My project was contracted still before the new regs came out, before the new EM 385 came out. So we're still under the 2014 EM 385.
Yeah, so are we, but I figured I updated it a little bit. So
Okay, no, that's good. It's good to hear the new stuff. Thank you.
Yep. Anyway, learning objectives for this training will be to sort of understand the whole process of fall protection programs. So that's, planning, hazard identification, and then execution of the work safely. We're also going to go over selection of suitable fall protection equipment, for the application, and then the enforcement of the standards. And, as a reminder, everyone has stop work authority. So if you ever see anything on the job sites, make sure that you're exercising that because it could, mean the difference between, life and death in certain these situations. So, so ECC has several policies that goes over fall prevention and protection. Our SOPs is 02-05, and you could find these on the EcoNet homepage. I recommend that if you're on a job as a safety professional, you familiarize yourselves with ECC's policies as well as whatever contractual obligations you may have on your contract. So what is the risk? Falls to a lower level account for approximately 1 in 3 of all workplace fatalities in the construction industry. Roofing is considered the third most dangerous trade, according to the Bureau of Labor Statistics. Falls remain one of the most cited OSHA violations, and they're always in OSHA's Focus 4. So, and by working at heights, I mean anything over 6 feet in the industry, construction industry. I updated this chart for the most recent statistics, and it hasn't changed much. But so you can see that roofers still is in the top 3 of most dangerous occupations. These are for civilian occupations, and this just goes to show you. I mean, how many times have you been drove past some residential construction site and seen everybody working on the roof and none of them being tied off? So you could see why there is so many catastrophic incidents relating to fall protection, because it is kind of a pain. You got to install anchor points and have everyone be tied off, especially on smaller jobs, is a pain, and a lot of smaller residential construction employers aren't going to enforce these rules. But if you work on a federal project, they will absolutely be enforced. So why it matters. Obviously, the loss of life or injury is devastating to families and coworkers. That's obviously the most important and has the most grave implications. But there's also a lot of financial implications for wanting to prevent these accidents. If a company has somebody get killed or seriously hurt on their job site, they're going to have higher DART ratings, higher recordable ratings, which leads to higher EMRs, which is experience modification ratings, which is higher insurance premiums. And if you have over, an EMR over, I think 1.1, or a DART rating over the industry standards, and certain opportunity you may lose out on future contracting applications opportunities because you just simply won't qualify. So it's really important. And there's also the the loss of reputation and harm to your company's safety culture. So these are some of the direct and indirect consequences. And as a prime contractor, ECC's reputation is very important. That's why we strive to have, excellent CPARS ratings and everything like that. So one bad incident can tarnish, an entire project's, goodwill and wipe everything out. So just make sure that you understand the implications of fall protection. So I'm under the understanding that all falls can be prevented through planning ahead to get the job done safely, providing the right equipment, and training everyone to use the equipment safely. So we're going to begin with the planning phase of creating a fall protection program. Fall prevention plans, or these are going to include your task specific AHAs that break down on a granular level each task, each how it's conducted, and how it's safely how all the risks associated with that task are safely mitigated, step by step. You're going to complete a fall hazard survey or fall hazard identification. So, what are the risks? Are people working on roofs? Is the roof flat? Is it a steep slope roof? And are they going to be, 30, 40 feet off the ground? Or are they 10 feet off the ground? These are all important aspects that will, dictate what type of equipment you're going to have and whether you're going to be using, passive fall protection means like guardrails, or active fall protection like, fall arrest systems. Another important thing that some people, contractors, prime contractors, whatever, forget to do is a structural analysis of the roof by an engineering firm. It's a requirement of the EM 385, and sometimes it's written in the spec sections of contracts. This basically verifies that somebody who is qualified has looked at the roof and it can support a construction load. Because what you don't want to have happen is you don't check and then you send people up on a roof to replace shingles or something, and they fall through a rotten roof deck and get seriously hurt or killed. And then also included in the fall plans, you're going to have your specific equipment that you're going to use. I ask our contractors to provide the cut sheets for the equipment they're going to use, so I know that it'll actually work for the application that they want to use it for. And you also want to verify the training of all the people involved. The selection of competent persons. The EM 385 has a 24-hour fall protection competent person training requirement, but they also have end user training requirements. So these are all parts of the fall prevention plan that you're going to package up and send to the client for approval in most cases. So there's always this hierarchy of fall protection, and as you go down, it gets less ideal. So it gets into the concept of fall prevention versus fall protection. So elimination, for instance, if the hazard is falling, you could alter or remove the task. For example, if you're going to change a light bulb, you use a staff instead of getting on a ladder to replace the light bulb. Or if you're going to hang ceiling grid, instead of getting up on a ladder, you use one of these lag poles that can install ceiling grid into the ceiling from the ground. Next is passive fall protection. These include guardrails. These are like physical barriers between you and falling. Guardrail systems are an excellent option for many low slope roofing applications, because once you set them up, the workers can be, not having to be tied off, and they could just get to work and focus on their task, and they don't have to worry about harnesses or anything like that. Next is fall restraint, not to be confused with fall arrest. Fall restraint systems restrict the worker's movement so that the worker's center of mass cannot reach, beyond the fall hazard. So basically, an example of this would be like somebody on a roof, on a flat roof, and they have a rope, and the rope is short enough so that they cannot physically reach the edge of the roof and fall off it, right? Next is fall arrest. This fall arrest is, a common control measure, and it's not ideal, but it is, it has to be used sometimes. And this involves the use of an anchorage, a body harness, and your connection means, to arrest a fall and prevent somebody from hitting the ground. And then lastly is your administration controls. These are typically the only thing allowed on this is like a warning line system, because they don't allow safety monitors. This is like your roof flagging. This is like provides the least amount of protection, but it is acceptable. But if workers do need to go on the other side of the warning line, they're going to have to, be tied off. So this is taken from an AHA. When you're working at heights, it automatically gives you a medium risk rating, because although you add controls so that it's very unlikely that somebody is going to fall off the roof. But if it does happen, it's going to be catastrophic. So if you look on the top right, it's going to be a medium risk code right off the bat when you're working at heights. So fall protection equipment, we're going to get into some of the specific equipment, do's and don'ts, how it's used. For fall protection equipment, it's the ABCs, your anchorages. These are commonly referred to, as anchor points. For roofing applications, there's many different kinds. For different substrates, they all have their own unique fastening patterns and fasteners that go with it. Some are permanent and some are, mobile and temporary. Next is body support. This is your harnesses. And then C is for connecting devices. This is the equipment that attaches your body harness to the anchors. These are your lanyards, your yo-yos, your SRLs, lifelines, all that stuff. All this equipment must be certified for fall protection and must be stamped with the ANSI Z359 stamp, which signifies that they've been tested and they're designed for these force ratings. For example, you can't just grab a 10,000 pound toe strap, and because it says 10,000 pounds, and and use that as like a lanyard or something like that. It has to be specifically designed, for the fall protection application. Our first thing I'm going to review is penetrative anchors. There are many different kinds and brands. They're installed into the structural elements of the roof deck or substructure. Like I said, there's many brands and configurations. They can go into different substrates like wood, metal, and concrete. An important thing with these is they're intended to be used for, certain directions of force, and so that means like not to side load. So if you look at the graphic there where it says it has the green arrows pointing down into the left and right, that's how that anchor is designed to be used. So if you apply force perpendicular to it, where it's with the red X's it says no, then you're doing what you're calling side loading the anchor, which basically takes away. It's not designed to operate like that. So if somebody does fall and you apply force in that direction, there's a chance that anchor could pull out. And it makes sense of it. It makes sense when you look at the anchor, above, and you think about it intuitively, because if you look on the far left, that's a concrete anchor. We call those. You can call them lollipops or whatever, and they're designed to be installed into a concrete deck. I think the minimum thickness is like 3 inches, so you got to make sure that you're not like drilling these into some like lightweight concrete decks or gypsum decks. That won't work. They got to be like a solid poured concrete form to install these concrete anchors. So Standing seam clamps, if you're on a project that's going to be doing any metal roofing, a really common product that the DoD likes to use is standing seam metal roofs because they're a superior product. So this specific two-way standing seam clamp has been used on many of my job sites. It's designed to be used in two directions, parallel to the ridge of the panel, and you want to install these only on fully seamed panels, and you want to make sure that it's torqued down to the specifications that is in the manual. And if you look in, this is pictured as a Guardian two-way standing seam clamp. So if you just like look up this product data, it'll tell you exactly what type of roofs it could be used on. Like for instance, this product can't be used on aluminum roofs. It's only for steel panels. So if you're installing an aluminum standing seam roof, you got to go with a different product. Malta Dynamics makes it a product that can be used for aluminum roofs. Another example of an anchorage is a cross arm strap or a beam strap, as we like to call them. Beam straps are a great application because they're super easy to install. You just wrap it around itself and then force the connector back through its loop, and you're good to go. You just got to make sure whatever you're tying off to is structural, meaning that it's tied into the building's frame, and you got to use your judgment in certain cases of whether or not it could hold, 5,000 pounds. For instance, in the picture here, this thing is attached to a structural steel beam that's holding a gigantic chiller on top of it. So for sure, that would be, I would rather tie off to this beam strap in this chiller unit than throw an anchor point into the deck and rely on screws personally. So if you can use these, go ahead and use them because they're a great option and they're fairly inexpensive. This next section, we're going to talk about non-penetrative anchors, and by non-penetrative anchors, I mean that you don't have to actually, fasten them to a roof deck or cause any damage to the roofing system to install them. These are great options, like when you're pretty much finished up with the roof and you don't want to put holes in your brand new roof. Sometimes they're complicated to set up. Like this one pictured here is used with another one down that it is not pictured. It's in a horizontal lifeline configuration, and it's fairly time consuming and cumbersome to set up. But once it's set up, it is a good application. You just need to make sure that what your roof deck can support the weight of it, because sometimes these non-penetrative anchors are kind of heavy. Fall carts. Fall carts are great because they're easy to move around and fairly easy to set up. This cart basically allows for 3 people to be in fall arrest on it. So that means you could throw 3 people and you can see they're working on the roof edge here. How it works is if they fall off the edge, a claw will activate and dig into the roofing system and, stop them from hitting the ground. So the downside is they are quite heavy and they're expensive. But they are a really good option, but they have to be set up right, and they can only be used on certain systems, and they can only be used on obviously flat or low slope roofs. This is some newer equipment that has come out recently. These are mobile fall protection towers. So this would be like an excellent option if you were going to go up on a roof and you weren't sure about having any suitable anchor points to tie off of, or this picture in the bottom left, like you can't like just start drilling in anchors or screws or anything into transformer stuff like that. So this thing can be backed up to your job site, and you could attach people to it, and it could serve as a mobile fall protection tower. So next is the body support, the B and the ABCs. So These allows for mobility while still supporting the body and dispersing, the force. That's why we use full body harnesses, because it takes the force of your fall and distributes it through your whole body. They have a max user weight range, so if you weigh too little or too much for these things, it'll say on the harness what the weight range is. It's typically 130 pounds to 310 pounds is like the typical weight range. And the green harness you can see on the right, it has these D-rings on the front that go on the belt. Now, I see this a lot on roofing jobs where, people they don't want to have the harness tied off to their back because, they have a rope or a cable kind of hanging over them the whole day. So I've seen people attach the harness, attach their lifeline to the front belt attachments, and that is not allowed. What these are designed for, these are positioning rings, so that if you were climbing, you could attach a cable or a carabiner, and you could take some of the pressure off of your body and position yourself with these. They're not intended to be used for fall arrest applications. So pretty much the only thing that is allowed is the rear dorsal ring for fall arrest. There are certain harnesses, like if you have a ladder climbing harness that has a D-ring in the front, and that's specific for that application. But, by and large, the connectors need to be attached to your rear dorsal ring, and it should be snug as well. So next I'm going to play a video. It should play, and you should be able to hear it. Real fast. Greg, did you have a question? Sorry, hand up.
Yeah, hey, I'm back to those guardrails that they have on their roofs for fall protection. I was just going to say, make sure that your subcontractor and, of course, the safety person is inspecting those daily, because those things get, make sure they're still secure and they're not falling apart and they're still workable, right?
Yeah.
Still in good use, because those things will, depending on what the system is, some of them, need to be maintained and managed. Basically, that's all I was just going to say. Thank you.
Yeah, that's a good point. All this equipment needs to be continually maintained, and guardrail systems, if they're the ones that screw into the perimeter of the roof, if there's like a windstorm or something like that, it could pull them out and knock them. You should be able to put 200 pounds of force on a guardrail, and it shouldn't really deflect more than a couple inches. So,
Good.
All right. So let me know if this video does not play, and I'll take your silence as it's working.
In this video, we're going to show you how to don a full body harness. Before you can use your harness, you need to do an inspection. When performing an inspection, it's best to hold the harness from the D-ring and shake it a little to get out all the tangles so you can get an organized look. Next, inspect the dorsal D-ring, making sure there aren't any cracks, scrapes, corrosion, or burrs that could damage the webbing. Also, make sure to check side hip D-rings and sternal D-rings if it applies. If D-rings are damaged, your harness should be taken out of service. Now it's time to inspect the webbing. Make sure it's free of fraying or tears. Also look to see if you notice any holes or burns from fires or chemicals. If you notice any of these things, the harness needs to be taken out of service. Some harnesses have impact indicators. If these threads are torn or damaged, it's an indication it's been in a fall, and the harness, again, needs to be taken out of service. If any of your straps have grommets, make sure they're not deformed or show any fraying around their sides. The final part of the inspection is the buckles. If you have a harness with self-locking buckles, make sure they're in good working order. Now you're ready to don the harness. Starting with one shoulder, put the shoulder straps on. Once your shoulder straps are in place, reach behind you between your legs and grab the leg strap. Buckle it and make sure it's secure. Make sure there's nothing in your pockets. During a fall, you wouldn't want something digging into your leg. After securing the leg buckles, make sure that any extra strapping is tied back so it doesn't get in your way while you're working. Your fingers should be able to slide between the strap and your leg with just a little effort, but there shouldn't be enough room to fit a closed fist. Now, buckle your chest strap and make sure it is in the middle of your chest. If it applies to your harness, secure the waist strap. Make sure your chest strap is not positioned too high. In the occurrence of a fall, it could choke you. If it's positioned too low, you could fall out of the harness. Last, make sure the dorsal D-ring is between your shoulder blades in the middle of your back.
All right. Yeah, it's really important that your harnesses are fitting correctly. If they're too loose or, they're not going to work right. So that's something that you could enforce in the field too. All right, trauma straps. These are required for harnesses. Basically, there's different kinds. There's some that go on your D-ring and some that go on the sides. They basically deploy like a little ladder so that if you do fall and you're hanging there, you could step into them and relieve the orthostatic, stress on your femoral artery. Because what could happen if you hang too long, it could cut off circulation on your femoral artery in your leg, and cause blood to pool in your legs, and it could be fatal actually. So it's really important that you have these and you know how to use them, and they are a requirement for EM 385 jobs. Next is lanyards. So lanyards are used to attach the harness to an anchor point. If they're used for fall rest, they have built-in force reduction designed to limit the force to the body. So on the left, you can see it's kind of scrunchied up. That means if it falls, that thing's going to rip out all that stitching and be completely straight. And as it rips the stitching out, it'll, reduce the amount of force. And on the right, there's what we call a bus pack, which is going to, open up and reduce the force on the body during a fall. They all require, self-closing snap hooks, and they have to be, designed for the application. I'm going to skip this.
Equipment inspection should be done before each.
All right. Connecting devices. Next is SRLs, self-retracting lanyards, or sometimes they're called SRDs, self-retracting devices. They're typically steel cable or nylon, and recently they had a 2021 update to the ANSI Z359.14 standard, and they reclassified the SRLs into two classes, Class 1 and Class 2. Class 1 is being for overhead anchorages, and Class 2 is for applications where overhead anchorages isn't feasible. I'll go into that a little bit more right here. So it used to be like type A and B, and it was sort of confusing. So they redid the standard. So basically, you got your Class 1, which is anchor is above the D-ring. This would be like if you were, building scaffolding or have somewhere where you could tie off above you. So that doesn't happen a whole lot in construction, especially in roofing. So typically you're going to want to go with your Class 2 anchors. So that means you could have the anchor point at above or up to 5 feet below the D-ring. And Class 2 means that it's also rated for leading edge, which means you could fall off the edge of a roof and the cable is designed to, not break or become cut by sharp edges. So your Class 2 SRLs is going to give you the most range for use on the job sites. So connecting devices, vertical lifelines or rope grabs. These are common options, and the pros is, it includes a shock absorber. They're inexpensive. You could use them for fall arrest or fall restraint. The cons are they require constant adjustment to limit swing fall. Basically, if you pictured you have like a 50-foot lifeline rope and your roof is 15 feet tall and you got 30 and you're at the roof edge and there's 10 feet of slack in that line, you're going to hit the ground even if you fall off the roof. So that's what I mean that, or if you go too far out from the too far of a working angle from the perpendicular to the roof edge from where your anchorage is, you will create what's called a swing fall, where if you fall off the roof, you'll swing until that rope becomes, straight to where it's attached to, and that could either cause you to hit the ground or hit something else. So that's the downfalls to using this type of system. They're a common option, and a lot of roofers like them because it's lighter on your body than having like a cable pulling on you all the time. But in my opinion, SRLs, retracting lifelines, provide a greater level of protection because it kind of takes out the human error factor of it because it automatically retracts as you move. Horizontal lifelines. There's many different variations. These make it so workers can, multiple people can tie off to a lifeline system. They have to be engineered. You can't just like make something up and say it's good. They're a good option. What you could do is you could install them on the roof edge or the roof ridge, and they have these sliding ring attachments so that pretty much the entire time your working angle is not exceeded. So it kind of helps eliminate the swing fall. And you can set them up at the beginning of your job and kind of leave them set up, and they're a good system. Rescue is another really important aspect of any fall protection plan. This is going to be an aspect of your plan that you have to submit. So either you do, self-rescue, like with the ladder, as shown in the picture on the left. This is basically if someone falls off the edge, somebody else can deploy the ladder and then climb up. Another way of rescuing is you could use an aerial lift, which I've had happen because I've had somebody fall off the roof and was dangling there, and we had to go save them with an aerial lift. You don't want to rely on the fire department as your primary means of rescue. It's actually not allowed. You have to provide your own rescue. Obviously, if you need help, don't hesitate to call. But they'll come out with a rescue ladder, and it'll be a lot better for you if something happens. That if you could take care of yourself, like take care of the situation yourself, like you're supposed to. And just remember, once somebody falls, and they're hanging there, the clock is ticking. You want to get them down as soon as possible because you don't want them hanging up there for anything more than like 10 minutes, something like that, because that harness hang syndrome could cause major health problems if they're left hanging there. So, and there's competent rescuers. They have to be trained to do the rescue. And this includes like the end user training. It's just being trained and briefed on what happens in the event of a fall. So training, fall protection program managers shall have a working knowledge of current fall protection regulations, requirements, standards, and equipment. A qualified person, a QP, shall be trained by a trainer with proper inspection, assembly, and use of all fall protection equipment. And your competent person, this is the person out there in the field who is enforcing the fall protection program, basically. And it's a minimum of 24 hours of formal training with a combination of hands-on and classroom training, and there's a 2-hour refresher required every year. And end user training is anyone, all the roofers, all the workers working at height, anybody who might be exposed to fall hazards shall have documented training of of the equipment and the hazards that they're exposed to. Types of roofs. So In the next sections, we're going to get more into the specifics of fall protection for specific applications that you may come into. Each type of roof requires different fall protection considerations and what may be feasible. So as you can see, there's different types of roofs, from the flat roofs to the gabled roofs, the hip roofs. They're all, once you get above, a 412 pitch and start getting into the slope roofs, you're pretty much limited to fall arrest applications. But flat roofs, there's a little bit more leniency and more products available to make it easier to provide fall protection. So pitched roofs require fall arrest system installations, and by pitched roofs I mean sloped roofs with the pitch greater than 412. So pictured is a Garland system standing seam metal roof with the aerial lift used for access. So when they were doing the demo, they were able to, this was a shingle roof, they were able to install butterfly anchor points into the over the roof ridge, and to provide fall protection. But then once they got the panels on, they were able to use those standing seam two-way clamps to provide fall protection. Flat roofs or low slope roofs are less than 412 pitched. Low slope roofs are considered 212 to 412, and flat roofs is considered less than 212. And if you don't know what pitch your roof is, you could sometimes find this information in your engineering drawings. So types of acceptable fall protection is either prevention or arrest. You could use guardrails, warning lines, fall restraint, fall carts, and other arrest systems. So steep slope roofs is roofs with greater than 412. This picture is an example of a very steep slope roof. These guys, you have to be very, very careful on these. You mostly, after you install your anchor point over the roof ridge, you're going to want to install some walk boards, some toe board nailers to kind of keep your balance on the roof. And in this application, I would actually use a rope grab or a vertical rope lifeline, because it allows you to keep tension on it, and you could kind of use it to sort of rappel down the face of the roof, and kind of helps you maintain your balance, kind of like as if you're rappelling. But you can use guardrails in certain situations. I wouldn't recommend it, or you can use safety nets. Their safety nets really aren't used too much, so it's pretty much going to be your fall arrest systems on these type of roofs. So again, yeah, your low slope roofs are going to have your guardrails, your safety nets, your personal fall arrests, or a combination of that, or warning lines. So earlier I talked about swing fall and safe working angle, and this is these diagrams I pulled from the Guardian temporary anchor cut sheets. Basically, you can see the person is standing at the roof edge, and the two red arrows pointing to the X's. That is the safe working distance, meaning he can go to the left or the right of that anchor point. That distance, as long as he stays within that safe working angle, then he is fine. And what I've done in the past is I requested that the subcontractor place the anchor point as far away from the roof edge as possible. So the further away the anchor distance from the leading edge, the greater the working distance is to the the left or the right of the perpendicular. So I'll go and say, all right, you are 20 feet from the edge. You can go 13 feet this way and 13 feet that way, and I'll just spray paint something on the roof and say, this is your safe working area. So if you stay within this boundary, you're going to be fine, and your system should work properly if something happens. Leading edge fall protection. So this term kind of gets thrown around a lot, but as far as like leading edge, but the what it means is the edge of a floor, roof, or formwork for a floor or other working surface, such as the deck of the roof, which changes in location as additional floor, roof, decking, or formwork are placed or constructed. So it's basically a fancy word for the edge of the roof where where the distance to the hazard, the fall hazard changes. So it's a unprotected side or an edge. Just consider it the roof edge. So that means your equipment has to be designed for that. For instance, if you are using a non-rated SRL, it could, have like a nylon lifeline. It could get cut if you go over a leading edge because, like there could be metal or something that could cut it. Next, controlled access zones. We refer to these as your warning line. Roofers like to use this because it's cheap and, it's allowed. Typically, you want these 6 feet back from the roof edge. On slope roofs, it's got to be 15 feet from the edge. The cable, rope, or chain used has to be 500 pounds rated. Side note, these flags that are in this picture right here will, inside of it is like a rope, but these little flags get tattered and, break down fairly quickly in the elements. So I've used 500-pound rated nylon rope, and I've added my own flags that consisted of red duct tape every 6 feet. And that's an acceptable method, and they last way longer. You can leave them up on the roof for like a year, and they won't break down. But basically, the idea is this creates like a no-go zone, and if you go outside the flagging area, then you're in the no-go zone, and you have to be tied off. So, and the flaggings have to be every 6 feet. There's specific cones and bases used for these applications. It has to be able to, I think, hold like 19 pounds of force without being deflected. So you can't just like throw up caution tape, because I've seen that a lot is people just get cones and they throw up caution tape and use it as a warning line. Like that's not going to work. It's got to be specifically designed for it. Guardrail systems are my favorite form of fall protection because they take out the human error factor, and they allow the workers full reign to focus on their job and not have to worry about harnesses and stuff like that. This system is uses 2x4s, so they just bring out a unit of 2x4s and the stacky ends get installed into the perimeter fascia around the roof, and they're good to go. So for these, the top and mid rails, the top rails have to be 42 inches plus or minus 3 inches, and the mid rail has to be halfway between the top rail and the floor, or the roof edge in this case. And they need to hold 200 pounds in each direction of force. And toe boards, which would be a third rail on the bottom that would go basically right on top of the roof. This would prevent you from kicking a can of caulk off the roof and it hitting somebody or dropping, or a tool rolling off the roof. They're required on all open sides ends at locations where a person is required or permitted to work underneath. So if you can't control your job site and you have people walking below you, you need toe boards, and that's the same on stair towers and scaffolding and stuff like that. Parapet walls. These are sometimes there's walls on top of flat roofs. If they meet the height and width specifications in the EM 385, then you don't need a fall protection system. So it's any combination of 30 inches or more in height plus a width that equals 48 inches or more is acceptable. So like if your wall is 40 inches tall and 10 feet wide, you're good because that total is 50, which is greater than 48 inches, if that makes any sense. So you basically, to figure out if your parapet wall meets the requirements as a fall protection barrier, then you just go and measure how tall it is and how wide it is. And if it's not, you may need to add one course of guardrail on top of it to make it an acceptable system. All right, so now we're going to talk about specific hazards with deck replacement and challenges when encountering, rotten wood deck. The left picture is replacing a metal canopy, so you need to consider the placement of the anchor point and swing fall hazards because it's a leading edge situation. This is kind of time consuming because you have to continually reinstall the anchor as you replace the panels, and you don't want to install a 16 fasteners in a brand new metal roof canopy, so you have to continue to have it on the old roof and keep adjusting it as you progress through the day. The right picture is a wood deck that has rotted out. This is tongue and groove deck planks covered with OSB plywood. It rotted out, and we knew it was rotted out in certain places. So now you have an area where you have to be tied off and basically treat this whole area as like a leading edge. So it's something to consider in investigations. If you have a roof that is leaking, and it basically water's going to go to the lowest point. So at the where the gables of the roof meet the roof edge is a good place to guess that you might have some roof damage. And this is kind of like where the structural analysis and inspection comes into play, because if you could get access into the roof attic or see it from below, there might be water stains or other information that's indicative that this roof deck is not stable. Roof access, ladders, extension ladders are a primary access point. Just to rehash, they need to be at a 4-to-1 ratio and extend 3 feet above the landing. You're basically going to want to use job approved NIOSH ladders, not anything job made. If it's in your contract, or if it could be in your contract, I recommend that you request that your roofers use stair towers, because it's by far the safest and easiest way to access the roof. It's basically a scaffolding system that allows for workers to get up on the roof at any time without having to mess with the ladder or anything like that. They're excellent. When you're building these, you have to be tied off with double lanyards as soon as it's feasible. So there is some risk to building it, but once it's set up, you could leave it set up for months, and it's a great way to get people on and off the roof safely. All right, mobile elevated work platforms, or aerial lifts, boom lifts, however you want to call them, man lifts, commonly used in roofing applications. They do require fall protection to the factory supplied anchor points within the basket. The lanyards must be static, meaning that they're not adjustable, and short enough to prevent the user from climbing out or being ejected. Because what could happen is these things don't really have suspension. So if you're driving down the road in one of these things and you hit a bump, that motion is going to be transferred all the way through the boom, and it could bounce somebody right out of a basket. And if they're not tied off, it's like a seatbelt that prevents you from being ejected from the car. It's like the same type of thing. So SRLs are not allowed in aerial lifts unless they're like specifically designed for that application. So there are some smaller SRLs that you can use, but it has to be printed on it that it's designed to be used in an aerial lift. So, and just so you know, the picture here is a kind of a specialty type of lift. This thing is called a platform lift. It's basically a giant deck platform that could be raised up to wherever you're working. It's a cool piece of equipment. Some other considerations is for aerial lifts is it does put the person right where you need to work, so it's good, but you also need to consider the stability of the ground you're tracking on. Be aware of your overhead hazards, electrical hazards, and as well as your tip over hazards. These equipments have alarms that are going to sound if it's getting out of whack, if it's not level. Don't ignore them. Don't let people bypass them. If it's sounding an alarm, it's for a reason. Sorry. Aerial lift fault arrest bar. Um, I wanted to bring this up because this is sort of a new thing. It's an aftermarket attachment designed to allow the occupant to utilize the machine as an anchor point. So these are great. Like if you're on a finished roofing system and you just need to like go do punch lists, like maybe add some caulk or something like that. You don't need to, and you need to get out of the basket. You can just hook up to this, and if somebody else is in the basket at the controls, another person can be out on the roof and not have to worry about installing an anchor point onto a finished roofing system. So this one's made by Genie, but you could put them on other lifts too, and United Rentals and other equipment rental companies have these you could get. Another huge hazard is skylights. They're a major cause of fall incidents, and typically it's because they get covered up and somebody just steps through them and falls to their death. So treat a skylight like a hole in the ground. It has to be regulated. If it's got a lot of times they'll expose the skylights and put roof flagging 6 feet back around them, or cover them with like 3/4 plywood or metal. If you do cover them, make sure that you write and spray paint hole on it, and some sort of danger thing, because that's a requirement. Sometimes these things have acrylic or plastic shells on them. Some of them are rated for force, but some of them aren't, meaning that they're not designed to have somebody step on them. And if somebody does step on them or fall on them, they're going to fall through. So if it's not, it should have like a little sticker on it. And if you're not sure, you could look up the manufacturer specs, or just assume that it's not rated and treat it like a hole. All right, now we're going to discuss some of the issues that I found on job sites, and if you guys have any things that you've encountered, you can chime in whenever you feel like it. All right, so this was, I remember this job site. It was a fairly new crew, and from the ground, it looked like both workers were tied off and using fall protection. You see that they have their anchor, their harnesses on, and they got their ropes attached. But this is where it's really important to, actually get up and inspect the equipment that they're using, because if you went up on the roof, you would see that looks like there's only 2 screws in this entire thing, where this was attached to a metal deck. So you would need 8 screws on each side of the D-ring for a total of 16 screws, first off, down the middle. And then you cannot have more than one person attached to an anchor point at one time. So there was 2 major things wrong with it, and we actually fired this group because it was apparent that they did not know what they were doing. So the takeaway is things can look good from the ground, but it takes somebody who's knowledgeable to go up and verify that the equipment is being used right. Because if someone were to fall, this for sure would not have held anybody. This was just for show. So next, the problem here is this is not the pin that was supplied with the system. This is just some screw. So it just goes back to the thing, you can't modify fall protection equipment, So you got to make sure that whatever is supplied by the factory, is what is used. So I recommend that if one of your subs brings on a piece of equipment, that you look up the equipment, specifications yourselves and how it's supposed to be used and the limitations, and hold them to that. So this was what I was talking about, swing fall. As you can see, this guy is standing at the edge of the roof. So if he were to fall, all that slack would be taken up, and then his bus pack on his lanyard rather would expand. So he's exposed to, way too much free fall distance. So he needs to tighten up that lanyard, or tighten up that rope. Another thing too is you don't want to cross ropes when you're up on the roof like this, because if one person falls, it could trip everybody else up. Um, that's why I recommend, if you're going to be doing this type of application, that you guys have them just use SRLs, because it takes away all the guesswork of it. You still have to have the correct working angle, and you can't side load your anchors, but it does help out a lot. So here's a picture. This is okay. This anchorage is okay. It's a huge steel beam with a chiller on it, but this is a rope lifeline connected to itself. This is a no-no. What you should use is a beam strap and connect the carabiner to the beam strap D-ring. You don't ever want to. Basically, these self-closing carabiners are designed to work on metal, not rope. So this is not how you would use this application. So here's a picture of an anchor point that will not hold your 5,000 pound requirement. So a reminder, every anchor has to hold 5,000 pounds for arrest and 3,000 pounds for restraint. That's a lead boot that's basically just nailed into the roof deck. If there's no way that's going to hold 5,000 pounds. It probably wouldn't even hold 200 pounds if you yanked on it, because this lead is pretty soft. This section goes back to proper harness fitment. As you can see, the harness D-ring is way too low. One of the straps is actually on his shoulder. So this is a smaller guy. This harness is too big for him, so he needs to tighten it up. Because if he falls, it could stretch too much and he could fall out of it, and the equipment won't work as intended. So we got a hole in the roof deck here. This roof could not sustain a construction load. That's why it's important to verify with an engineer or a qualified person that wherever you're going to go to put guys up on there, that it's safe to do so. In this case, a worker was tied off to another roof that was, and this is like just an added canopy. So he was fine. He had an SRL attached to him. He just kind of stepped through it and he was fine. But it's just a reminder that, sometimes the RFPs come out, especially for these storm packages, and there's, maybe a year and a half before you actually get out to the job site and finish it. So sometimes the site conditions have changed, and most times gotten worse. Like if you have a roof that's leaking, it's not going to get better, it's only going to get worse. So that's why you want to treat every job brand new and come out there with a fresh set of eyes and make sure that you're not putting your guys in danger. All right, takeaway. So for this main takeaway, planning, know the site conditions, know the hazards, have a detailed fall prevention plan and AHAs tailored to your task. Choose the right people for the job and verify that they're, trained and adequate. Proper equipment selection. There's a lot of projects out there. Make sure that what's being used is appropriate for the situation. Inspect the equipment, know when fall restraint and fall arrest is to be used, and then lastly, verify, fight complacency and make sure the subs are aware of what they signed up for before they show up. A lot of times people just show up thinking that, they're just going to work like they work outside of a base, like on typical residential jobs, and they're very surprised with all the rules and regulations associated with fall protection. So make sure everyone is aware before they start. Speak up, and if you see something, say something. All right, that's it. If anybody has any questions or comments, go ahead. All right, great. Thanks, everybody. Appreciate your time.
Good job. Thank you.
Thank you. Stay safe, guys.
Thank you, sir.
Thanks, Andrew.
Thank you.
Thank you. Thank you.